So let's start with number 43. According to the equation for the reaction represented above, which of the following statement is true? Choice A. If 2 moles of aluminum are used, 1 mole of iron is produced. We know that that's false, because for every 2 moles of aluminum used, 2 mole of iron is formed, not one mole. So the ratio is 2 to 2 between Al and Fe, but choice A says 2 to 1, so that's not true. This is not true. Choice B, if 1 mole of aluminum is used, 0.5 mole of iron oxide is consumed. Now, this may be the correct answer, so let's just mark it, because in the chemical equation it says for every 2 mole of aluminum, 1 mole of iron oxide is consumed, but when we cut it down to 1 mole, so 2 mole to 1 mole, that's basically multiplying by half. We're just dividing it by 2, right? So when we divide the number of moles of iron oxide by 2, that's also half. So choice B might be the correct one, but let's keep reading. Choice C, if 1 mole of aluminum is used, 1 mole of aluminum oxide is produced. That's not true, because for the ratio between the aluminum being consumed and the aluminum oxide being produced is 2 to 1. This is also not true. Choice D, if 0.5 mole of aluminum is used, 1 mole of aluminum is produced. Now this is not true, because for 0.5 mole of aluminum to be used, we just have to divide this equation by 4, right? So 2Al over 4, basically 0.5 Al. And we see in the equation for every 2 Al, 1 mole of aluminum oxide is formed. But if we divide 1 mole by 4, it's 1 over 4 moles, or 0.25, so that's incorrect. Choice E, if 0.5 mole of aluminum is used, 0.5 mole of iron oxide is consumed. We know we know right away that's not true, because to start with, the ratio between aluminum and iron oxide is different. So we can say that the correct answer is B. 44. Which of the following combinations of particles represents an ion of net charge -1 and of mass number 80? Now, in our first video, non-SAT video, we learned that mass number 80 means the number of protons plus the number of neutrons, right? So basically, within the choices, if we have the number of protons and number of neutrons that do not add up to 80, we can instantly eliminate that choice. So this is incorrect, and yep, that would be the only one eliminated so far, right? Okay. So if it has a net charge of -1, that means it has +1 E minus compared to the proton. So here it seems like the element has a atomic number of 36. So an element that has an atomic number of 36 is krypton. Or actually, okay, please edit this. So net charge of -1 is basically +1 electron, and we know that in a neutral atom we have the same number of, in a neutral atom, number of protons equals to the number of electrons. So we just have to find a choice that has +1 electron compared to the number of protons. Now, choice B has more protons than electrons, so it can never be a negative charge. Choice C, let's see. Choice C has equal number of protons and electrons. That cannot be the answer, because that'll just be a neutral atom. And choice D, it's all another neutral atom, so 44 would be E, because 45 neutrons plus 35 protons equals to 80, and it also has a net charge of -1. Number 45. Colored complexes of transition elements have color because they... Now, the answer for this is actually because transition metals have half-filled d orbitals. That's actually the correct answer, but we don't see that in the choice. So we have to pick the one that is most appropriate. Let's see. Choice A, have very high formation constants. That has nothing to do with it having colors. Oops, so that's incorrect. Choice B, absorb light of some visible wavelengths. So that might be the correct answer. Number C, absorb light of some ultraviolet wavelengths. Now that's false because ultraviolet wavelengths are not visible. And choice D, have unpaired electrons. Not necessarily. Choice E, are soluble in water. That's not because they have color, because also sodium chloride is soluble in water, but they don't have color, right? So the choice is B. And the explanation for this is, for a substance to have color, for any substance to have color, let's say the color of this solution is red, that means it absorbs every wavelength of visible light. So let's say green, purple. I'm just naming these specific wavelengths as their color, right? Purple, yellow, and blue, let's say. So it absorbs all these colors, but the only color being reflected is red, and that's why in the human eye we see that the color is red. So basically the color that anything is basically the one wavelength that the object reflects. That also goes to plants. They're mostly green because they reflect the green wavelength. So choice B is the correct answer, because it says absorb light of some visible wavelength. So that means some visible wavelength is also reflected, therefore it has color. So the choice should be B. 46. When 100 grams of O2 are allowed to react completely with 1 mole of C2H4 according to the equation above, which of the following results? Okay, so for this question, let's form an ice table. Okay, so we form the ice table. We say that 100 grams. So 100 grams of O2 is basically, you just need to do 100 over 16. So let's do that. So 100 over 16 equals to, oops, actually it's O2. So you need to do 32 because the molar mass of O2 is 32. So let's do 100 over 32, and we know that it's 3.125 moles. So this is supposed to be, just leave in fractions because you're not allowed to use calculators in the actual exam. And it's allowed to react completely with 1 mole of C2H4. Right, okay, so that's 0, and the change will be -1 mole because they have to be an equal ratio. You see that the ratio between the C2H4 and or ethene and oxygen is 1 to 3, so you need to keep that ratio that says -3 moles, and you add 2 moles here and add 2 moles here because you also have to follow this ratio 2 to 2. So we basically have 0 there, and 32 times 3 is 96. So 100 over 32 minus 96 over 32 is basically 4 over 32, which is equals to 1 over 8. So 1 over 8 mole remains, and we have 2 moles, and we have 2 moles. So let's see the choices. Some C2H remains unreacted. That's false because the excess reactant here is the O2, right? choice B, some O2 remained unreacted. So that should be correct, but let's keep looking if there are any other choices. Only CO2 and H2O are present when the reaction has run to completion. That's not true because there's also some amounts of O2 left, as you can see in the results. So that's not true. D, less than 2 mole of CO2 is formed. Nope, exactly 2 moles are formed, so that's untrue. E, the partial pressure of O2 falls to 0. That's untrue because if there are some amounts of O2 present, there has to be a partial pressure, so the choice is B. Number 47, when the equation for the reaction represented is balanced, completed and balanced by the use of lowest whole number coefficients, the coefficient for Ag plus or Ag with an oxidation state of 1 is, so all we have to do here is to form Ag2S, right? Because so that Ag has an oxidation state of +1, sulfur has an oxidation state of -2, so that their overall oxidation state will be 0. So what do we have to do here? We just have to add 2 and 1. So the coefficient is once again B, or 2. The oxidation state of nitrogen is most positive in which of the following compounds? So let's break down each of these. And here we know that oxygen and nitrogen oxides are always -2. Okay, so here the total oxidation state of 3 oxygens are -6, so we know that nitrogen is +5. So in NO3 minus, the oxidation state of nitrogen is +5. In NO2 minus, -2, we do that as -4. Total oxidation state is -1, so that should be +3. So we immediately know B is not the answer, because the question is looking for the most positive oxidation state of nitrogen. And N2O, let's see N2O. That should be -2, and that should be +1, so that's not true. For N2 it's just 0, so that's also not true. For NH3, let's see. For NH3, the oxidation state is actually minus. So that's +1, that's -3, that's not true. So obviously the answer would be A. 49. Products of the reaction represented above include which of the following? So here we see a reaction between an acid or an hydronium ion. We see hydronium and we see a carbonate. So let's see what happened when an acid and a carbonate react. So basically acid plus carbonate, they produce water, salt, and CO2. So let's see. They do produce H2O, liquid H2O. Now you gotta also focus on this symbol here, which is this symbol right here, which is a state of a substance, or rather liquid for water and gas for CO2. There's actually some trick questions that they actually change this state of matter symbol. For example, they're gonna write like CO2 solid, which is definitely not the product. So yep, keep that in mind. So here the answer should be water and CO2, as the products are water and CO2. So why is it not magnesium or Mg? Because magnesium is not a solid, it's a metal. So that should not be true, and the choices are just D. That's the correct one. Fifth, of the following, the field of organic chemistry is least concerned with the study of, let's see. So organic chemistry is basically a field of chemistry that studies carbon, right? So basically petroleum are hydrocarbons, so they do have carbon, so this is basically not true. Polymers also have carbon, not true. Carbohydrates, they also have carbons. Alcohols, they're actually one of the functional groups that looks like this, so That's also not true. It should be alloys, because alloys are basically the mixture of metals, which has nothing to do with organic chemistry. Number 51. According to quantum mechanics, correct statements concerning the electron and the hydrogen include which of the following? So for this, the answer is just the second one, or just B. And these are just one of the things that you know. Moving on to number 52, the conversion of chromate ion to chromate 3 plus during a chemical reaction is an example of. Okay. Let's calculate the oxidation state of chromium in the chromate ion, right? Okay. -2, the total oxidation state is -14, so that should be +6, right? Because the total oxidation state of the chromate ion is -2, so just add 2 there, -12. There's 2 chromate ions, and divide that by 2, and you get +6. So it's +6 there, and so 6 plus turns into Cr3 plus, and that means that here you have 3 minuses, and basically the losing of electrons is called oxidation, or oxidation rather. So that should answer should be E. And in contrast to that, reduction is basically the addition or the gain of electrons. 53. Oxidation reduction process include all of the following except. It's not A, because all combustion reactions are oxidation reduction reactions. Rusting of iron is definitely oxidation reduction. Generation of power by your storage battery, that's definitely oxidation reduction. Combustion of gasoline, combustion reactions. Conduction of an electric current in a copper wire, that's not an oxidation reduction reaction, because it's just a strip of copper, or copper wire rather, and just electrons passing through it. That's nothing. That's not an oxidation reduction reaction, so it should be that. E. Characteristic features of naturally radioactive elements include which of the following? Okay. Choice 1 is the emission of alpha or beta particles or gamma rays. Choice 2 is a characteristic half-life. Character 3 is spontaneous decay. These are all true, because every radioactive element does have a half-life, which means that they decay in an amount of time, and in a specific amount of time they will basically half in mass. And all radioactive elements are radioactive because they either emit alpha, beta particles or gamma rays. 55. What mass of lead nitrate? Molecular formula. A molecular mass of 331 is needed to make 100 milliliters of a 1 molar solution. Okay, so to make a 1 molar solution, this is basically the formula for molarity, right? So basically you need 0.1 moles of lead nitrate in 100 milliliters of solution, because this is always in liters. This is in liters, and this is in moles, right? So 0.1, 331 equals to 1 mole. So 0.1 mole equals to 331 over 10, or 33.1. Choice is E. 56. Which of the following can be expected to increase the rate of reaction given by the equation above? Okay, so this is basically talking about which of the choice will increase the rate of reaction for the equation above. Adding some helium gas, that will not help, that will not change anything. Adding a catalyst, yes, that's definitely true, because a catalyst lowers the activation energy. Increasing the temperature. Now, if we increase the temperature, according to Le Chatelier's principle, if you increase the pressure here, the reaction will tend to shift to the right, so that's also true. So the answer should be, not 1, should be 2. 2 and 3 only, D. An example of a network solid is diamond. A network solid is basically a complicated, or rather a compound that has network covalent bond, which is a complex type of covalent bond, which is not limestone. Table salt is ionic. Limestone is ionic. Dry ice is covalent, but it's not a network solid. And iodine also not a network solid. Okay, number 15. The diagram shows that the reaction between X and Y to form Za had come to equilibrium at time Ti, or T1 rather. The equilibrium shifts that occurred after time T2 were most likely caused by which of the following? Okay, now we see a drastic shift in T2 here, so what can be the choices? Choice A, adding more X and Y to the equilibrium mixture. Choice B, adding only more X to the equilibrium mixture. Adding only more Y to the equilibrium mixture. Increasing the temperature, increasing the pressure. Okay, so for this question, we see this this increase here, and we see that it's most prominent in the X and Y graphs, and it's quite plateau in the Z. So we can know that the answer is A, adding more X and Y to the equilibrium mixture. Number 59. 5 mole sample of oxygen gas is added to a vessel that contains 1 mole of hydrogen gas and that is maintained at a constant temperature. No chemical reaction occurs. The volume of the vessel remains unchanged. Okay, so it says a 5 mole sample of oxygen gas, or 5O2, is added to a vessel that contains 1 mole of H2 gas and that is maintained at a constant temperature. No reaction occurs. The volume of the vessel remains unchanged. Now, the ratio of the pressure exerted by the oxygen gas to the ratio to the pressure exerted by the hydrogen gas. So this is basically you just need to know the molecular mass, the molar mass of these. So this is basically 32, right? Okay, for this question, yep, we know that it has 5 O2s and 1 H2s. So basically the answer is just going to be B, because for the the pressure exerted by the gases, you don't really need to focus on their molar masses or anything. You just need to focus on this mole number right here, because all gases at constant temperature occupy the same volume, or all ideal gases rather. And in SDP they occupy 22.4 liters, and at RTP they occupy 24 liters per mole. So it's 5-1 because there are 5 moles of O2 and 1 mole of H2. So number 60. After the gases are uniformly mixed, the partial pressure exerted at the walls of the vessel by the hydrogen gas is, now after the, okay, so the answer for this should be okay, so the formula for partial pressure equals to P1 plus P2, and because there are only 2 gases here, right? So this should be B, the same as before the addition of the oxygen. Now why? Because the addition of oxygen does not change the pressure of the hydrogen, right? It just adds on to the partial pressure because there's more gas introduced. Number 61. For a particular compound, which of the following pairs can represent the empirical and the molecular formula respectively? So empirical formula is basically like, you can think of it as a simplified format of molecular formula. So for example, if you have C2H4, the empirical formula can be CH2 or something like that, because you both divide these numbers by 2. So let's see. Number A, CH3 and C3H6. This may be the choice. CH2 and C2H, that's not the choice. That's not the correct answer. CH2 and C3H9. If this were to be correct, it's supposed to be just CH. And for this to be correct, it'd be CH3, not CH2. And choice D may be correct. So let's say that actually no, choice A is incorrect, because for C3H6 it has to be CH2. Rather, it says CH, that's incorrect. E, CH and CH4, that's also not correct. The choice is B. Or D, rather. Correct statements concerning the process above occurring 100 degrees include which of the following? The vaporization process is endothermic. That is true because when water turns into gas, or rather when H2O liquid turns to H2O gas, the H bond in the liquid, because H bond in liquid, or the hydrogen bond in the liquid, are stronger, H bonds are broken. And when bonds are broken, or when bonds being broken are basically equal to endothermic, because when bonds are being broken, they need energy, and when bonds are formed, they are exothermic, because when bonds are formed, they release energy. So basically, freezing is exothermic, melting is endothermic, vaporization is endothermic, condensation is exothermic. So it's the choice 1 is correct. Number 2, the randomness of the system increases during the vaporization. That's true, because as liquid turns to gas, its molecules move more quickly because they get more energy. Choice 3, the average potential energy of the vapor molecules is greater than that of the liquid molecules. So this should also be true, because they move faster, therefore they have more potential energy than the liquid molecules. That answer is E. Number 63. Which of the following statements about the halogens are true? A, they all form X- ions. That's true, because all halogens have 7 valence electrons. So they just need to add 1 more electron to form ions, which is all minus. For example, F minus, Cl minus, Br minus, and I minus. B, they have the lowest ionization potential. This is not true, because the group that has the lowest ionization energy it says lowest ionization energy of the elements in their respective periods. So in their respective periods, it should be the alkali metals that only has 1 electron that has the lowest ionization potential. That's not true. C, they're all solids. Nope. Fluorine is a gas, chlorine is a gas, bromine is a liquid, and iodine is a solid. D, they're among the best reducing agents. Nope. Reducing agents, remember, are not ones that get reduced or gain electrons, but rather reducing agents are like the agents that help a substance to get reduced. So they have to be oxidized themselves to be reducing agents. So basically, reducing agents are oxidized, and oxidizing agents are basically reduced. So reducing agent would be alkali metals. That's not true. E, they all react with water to form basic solutions. That's not true, because fluorine, chlorine, bromine, and iodine, they all react to form acidic solutions, or hydrofluoric acid, hydrochloric acid, hydrobromic acid, and hydroiodic acid. That's not true. So the answer should be A. So that's it for now, and if you have any questions, feel free to comment down below. Check out my Instagram, and don't forget to join the Discord channel, because that's where chemistry students will be to answer your questions if you have any.